Alright, grade 11s, I'm just doing a walkthrough of the exercises that I have said are kind of valuable for you in your textbook and the questions. This memo has all of the answers from exercise 1 to 5, but I'm going to just walk through the ones that I pointed out in my last video that I think you should work on. Alright, for exercise 1, that is completely revision of grade 10 Pythag questions. So for question A, they've given you that negative 5 sine theta equals 4. So take the 5 across and then ask yourself, where is sine going to be negative? And use your other clue there. So sine would be negative in tan and cos's quadrant. And then from 90 to 270 is quadrant 2 and 3. So quadrant 3 has the double tick. That's why we've drawn our triangle there. We do our Pythag. First of all, sine is opposite over hypotenuse. So that's how we get opposite hypotenuse in our triangle. Then we use our Pythag here. And don't forget, we are working in the negative region for x. So x must be negative. All right, then, excuse me, then all you have to do is, so where you see a cos theta, you're going to do adjacent over hypotenuse in your triangle. And then when you have a tan theta, you're going to replace it with an opposite over adjacent. So we don't want any coses or thetas or tans and thetas left over. You have to put a fraction ratio. And then you just work it out. Same thing for the next one, where you see a sine theta, you go to your triangle and you work with your fraction opposite over hypotenuse for cos adjacent over hypotenuse. Alright, then for B is using a new situation. They have given you that 2 cos theta plus 1 equals 0. So cos is negative when you get it by itself. Sine is also negative, so the only place where cos and sine are both negative must be in tan's quadrant. Alright, so sine is negative in tan and cos's quadrant, cos is negative in sine and tan's quadrant. So you get the double overlap there in tan's quadrant. Alright, then you're working with Pythag, and just remember, because we're working below the x-axis here, your y value must be negative. And then you just fill in exactly what we've done already. So where you see a tan alpha, you go to your diagram and you look at opposite over adjacent. For sine, you look at opposite over hypotenuse, and you work with it in your calculators or in your heads. Same thing here. Just remember, there's a squared. So where you see a sine alpha, you're going to put opposite over hypotenuse, but you're going to square it. Cos squared, you're going to have opposite adjacent over hypotenuse, and you're going to square it. And then you just work it out. All right. So then moving on to the next question. Question C is where is tan going to be negative? And they've told you you're working from 0 to 180. So you're going to say, where's tan negative? Sine and cos. So sine and cos. But then where are we working? 0 to 180 is quadrant 1 and quadrant 2. So the double tick is in quadrant 2. So then we're working with Pythagoras. Our radius is always going to be positive, so you take only the positive root 13. So when you square root, remember, you go plus minus. So you take only the positive answer for the radius or the hypotenuse. All right. Then where you see cos beta, you do adjacent over hypotenuse. Sine squared, you take opposite over hypotenuse all squared. Cos is adjacent over hypotenuse. Sine squared again is opposite over hypotenuse all squared. Alright, so you use your triangle. Opposite over hypotenuse, adjacent over hypotenuse, etc. as if you're working from this little angle. So now, based on the fact that you've learned through the other videos that reductions happen, that's why this big angle here, that whole thing is beta. But we take it as a small one because a small acute angle can be made equivalent to a large angle using reductions. All right, then for D, we're working with where is sine going to be positive, because it's positive 12 over 13, and our angle must be between 90 and 270. So sine is positive in first and second quadrant, and whereas 90 to 270 is second and third quadrant. So we're working in the second because that's where our double tick is. Then again, you're working with Pythagoras because your x is on the left-hand side of the y-axis. You're working with a negative x. So plus minus 20, the root of 25 is plus minus 5, but we only want the negative 5. So then when you see a tan alpha, you're replacing it with opposite over adjacent from your triangle. Then cos squared, sine squared, cos squared and sine squared, you are taking adjacent over hypotenuse, opposite over hypotenuse, squaring both of them and working it out. Where you see a cos A, you replace it. Tan A, you replace it. Okay, so we don't want coses, sines, tans, or A's left in the final answer for these number types. Then for E, the clue is that cos must be negative, and you're working between 180 and 360. So that is cos is negative in sine and tan's quadrant, and 180 is tan to 360 is cos. So our double tick is in tan's quadrant in the third quadrant. All right, then by Pythagoras, you're working out your y value is negative 15. And again, it's negative because we're working underneath the x-axis. Then you're going to take your triangle and then fill in for sine, it's opposite over hypotenuse. For tan, it's opposite over adjacent, but it's being squared. Sine, again, opposite over hypotenuse, but it's being squared. And then you work it out numerically. Sine, again, opposite over hypotenuse. Tan, opposite over adjacent. Okay, so get rid of the sine, coses, tans, and the angle. Replace it with fractions from the triangle. Okay. F is, again, very similar. So for F, we're working with where is tan going to be negative. So once you rearrange it, get tan by itself. Where is tan going to be negative? It's going to be in sine and cos's quadrant. But then they said to you here, cos must be positive, which is first and fourth quadrant. So we're working in the double tick region, which is cos's quadrant. In this situation, they have given us the opposite and adjacent. Your x value must be positive because of where we're working on the scale, and the y value must be negative because we're working under the x-axis. Your r value or your hypotenuse is always going to be a positive answer. All right, so then we're working with your triangle, and again, it's your replacing with your correct ratios. Opposite over hypotenuse, adjacent over hypotenuse. Same thing for number 2, except you are squaring your answers. All right, for G, it did have a star in it, but the only thing is it's just because the clue's a little bit harder to read into. So let's just look at the second clue first, because that's normal. Between 90 to 270 is from quadrant 2 to quadrant 3. Right, but then they tell you something very different to what you've seen before. So it says sine theta is equal to negative k over k squared plus 9, but k must be a number between 0 and 3, not including it. So it can be 0,5, it could be 1, it could be 2, anything like that. So let's say it's going to be 1. The aim is not to solve for k here, so I just want to show you what the effect of this clue is. So if I have negative 6 times 1, I have negative 6. 1 squared is 1, that gets us 10. So either way, it doesn't matter what we're working with. It's just saying to us that sine theta is going to be negative. All right, so if I were to use the number 2, negative 6 times 2 over 2 squared plus 9, I'm going to get negative 12 over 13. So it's just helping us with the clues, saying that because we don't know what k's value is, if you were to use any of the possible values from 0 to 3, not including 0, not including 3, you're always going to get a negative at the top, a positive at the bottom. So in that case, they're just telling you that your sign must be negative, which sine is only negative in tan and cos's quadrant. And then from that point onwards, you have your normal situation of quadrant 3. You have a triangle there. Okay, the only thing is, remember, for sine, we're working with opposite over hypotenuse. Opposite over hypotenuse. So from this inside point here, opposite is going to be negative 6k. Hypotenuse is going to be k squared plus 9. Now, k squared plus 9 will always be positive, because when you square anything, whether it's positive or negative, you're always going to get a positive answer, and then you're adding onto it. So you're going to get more positive each time. So your radius is fine there. It is positive. All right. And so then we're working with Pythag now to find our x value. So unfortunately with Pythag here, you're going to have, remember, it's your hypotenuse squared is equal to your other two sides added together and squared. So now if I get x by itself, x squared by itself, I take that negative 6k all squared across, and that's what I get here. So you can go straight to that first step of the rearranged Pythagoras. And then so you're working with foiling. So you've got to foil that first bracket, and then you've got to just rearrange everything. So you end up with k to the 4 minus 18k squared plus 81, which is a trinomial. If you need, you can let k squared, that middle term, equal, let's say, p. You'd make it p squared minus 18p plus 81. And then factorize like that. But the idea is that your factors are going to become k squared minus 9, k squared minus 9. So it's a perfect square. So your final answer is x squared equals bracket squared. So you can drop the squared, square root both sides. And remember, because we're working on the left-hand side of the y-axis, your x value is going to be negative. All right, so you're ending up with a triangle. Let's just put it down here. With negative k squared minus 9, negative 6k, and k squared plus 9. So that is your triangle. So you're working from here. So when you're asked to do for the next questions, where they say cos theta for number 1, cos is adjacent over hypotenuse. All right. Now just be careful. You can't cancel them. They're not the same. Okay. So you have to leave it as that fraction up there. Then for tan, try highlighting, tan and cos here. Tan is going to be opposite over adjacent. Cos is going to be adjacent over hypotenuse. All right. So now in this case, you're going to have to do a tip and times with that fraction. And then you're going to work with an LCD, which they happen to have the same denominator. And then you've got to distribute on that top piece there. Right. Then the idea is to try and go as far as possible. The denominator ends up being a dot. Your top ends up being a trinomial you can factorize. And so you can end up cancelling two of the brackets, and you simplify down to that bracket. So G is just a lot of algebra going on. So, and I think that 0 to 3 for K might have thrown some of you. It's just telling you sine is going to be negative. And then the rest, honestly, besides the opposite of hypotenuse, the rest is a lot of algebra. So it's a nice question because it really tests your integration of skills. All right, we're going to move on to the next exercise now. All right, grade 11's exercise 2 is on the new work, so that's why I'm obviously going through it with you. I said try all of the questions just to get into it. So I've drawn the cast diagram here. Please, you have to learn it off by heart. So for question A, it says sine 180 minus. You need to recognize that 180 minus lands us in sine's quadrant. All right, so then we know that sine is going to be positive. The whole point of this cast diagram now is to reduce angles to smaller ones. So the idea is to be able to get rid of that 180. But because we're working in sine's quadrant, we land up with a positive answer for sine. Then sine of 360 minus theta lands us into cos's quadrant. Right, so cos's quadrant is for cos only. So anything else is going to be negative. So that's why this plus here in this question changes to a minus there, because sine is going to be negative. But the whole point is to reduce and get rid of big angles. So we get rid of the 360. We incorporate it by using the negative from that quadrant. All right, so you need to know what quadrants we are working in. Okay, let's get rid of all of that. Okay, so then now for the next one, cos of 180 plus is taking us into tan's quadrant. Just because it's 180 plus x, it doesn't matter if it's theta or x, as long as it's 180 plus an angle, plus a variable. So cos in tan's quadrant is going to be negative. Right, so we drop the 180, we reduce it, we get rid of the big piece, and then we apply the correct sign according to the quadrant we're in. So then, cos of 360 minus x. 360 minus is in cos's quadrant. So we keep the cos as is, drop the 360, and so it's positive cos. And so then you end up with negative cos x minus a cos x, which means we have negative 2 cos x's. It's like saying negative x minus an x. All right, I'm hoping you're understanding this. Again, we will have some time in class to go through this. It's just nice for you to try and get your hand on this somehow. So then for tan of 180 minus, that is in sine's quadrant. So tan is negative. We drop the 180 and we use the overall positive or negative from the quadrant. But tan of 180 plus is in tan's quadrant, so tan is happy, it is positive. But tan over tan is 1, and don't forget your negative. Then we have sine of 360 minus. That's in cos's quadrant. So we are dropping the 360, but we are implementing a negative because we're in enemy quadrants. We're in cos's quadrant with sine. Same thing with sine of 180 plus. We are getting a negative because we're in tan's quadrant. Now, the only thing I disagree with here, they should have brackets because otherwise it looks like subtraction. So then you have a sine times a sine is a sine squared, and negative times a negative is a positive. All right. So then for the next one, and hopefully you're seeing how important this cast diagram is. Cos of 360 minus, that's in cos's quadrant, so cos is positive. Tan of 180 minus is in sine's quadrant, so tan is negative. Again, remember, we're dropping the big part of the angle to make this smaller and easier to work with. Then, cos of 180 minus is in sine's quadrant, so it's negative. And then all we're doing is a little bit of algebra. Our coses can cancel, our negatives can cancel, and we're left with just tan theta. Right, so then for F, sine of 180 minus, that is in sine's quadrant, so it's positive. Tan of 360 minus is in cos's quadrant, so tan is negative. Sine of 180 plus is in tan's quadrant, so enemy territory, we are working with negative sine. And then again, our sines can cancel. Sine and sine, our negatives can cancel, and we're left with just tan. Second last one, G. we are working with 360 minus with tan, which is cos's quadrant. So if you need it there. So tan is negative. Tan of 180 plus is in its own quadrant, so it becomes positive. And then, please be careful of this one. Tan of 180 minus x, but we're squaring it. So we know we're in sine's quadrant for 180 minus. So we're going to get a negative tan x, but we're squaring it. When you square a negative, it becomes positive. When you square tan x, it's tan squared x. So that's how we've randomly got a positive here, even though we're working in sine's quadrant, because we're working with a double negative, which is getting us a positive there. Then a step that they've kind of missed out there. That top is becoming negative tan squared x, because it's a negative times a positive, tan times tan, all over tan squared x. So our tan squared and tan squared can cancel, and we're left with just negative 1. All right. Then for h, we're working again, same thing with the square. So when you're squaring, it actually doesn't matter what quadrant you're in, because you're always going to get a positive. So because sine of 360 minus is in cos's quadrant, we're supposed to get a negative sign answer, but we're squaring it. So squaring a negative is a positive, squaring sine is sine squared. So that's where this piece is coming from over there. All right. Then same thing with cos squared, but it is in cos's quadrant. So either way, you're getting a positive cos and it's being squared. Again, please preferably put brackets. It's much better. Then sine 180 plus is in tan's quadrant, so it's going to become negative once you drop the 180. And then sine of 180 minus is in its own quadrant, so it stays positive. Then, again, they're missing out a step at the bottom, where that actually becomes negative times positive is negative, sine times sine is sine squared. So we're cancelling our sine squareds, and we're left with then a cos squared with the negative. All right. I'm really hoping this is making sense for you. Nice thing about the videos is you can stop and just go back and re-listen to it. Okay, moving on to exercise 3 now. Okay, for exercise 3, I said just try the ones that I've given on the previous video, A, C, E, G, I, K, M. All the answers are here if you did try more, and I will be posting up the memo separately as a PDF as well. So I'm just going to go through the ones that I highlighted that you should do. All right, so for question A, it's just mixing everything that I've taught you already in the previous videos. So tan of 360 plus is a greater than 360. So remember, when you have 360 plus, you're adding on to 360. Just subtract the 360 off, or work as if you're in the first quadrant with 360 plus, because you're going beyond 360. But if you minus 360, you're just left with tan theta. Then you're working with your negative angle rule. So you have to go back to the notes. Cos of a negative angle is positive cos. Then a reduction here, cos of 360 minus is going to be in cos's quadrant, which is positive cos. The coses then cancel top and bottom, and you're left just with tan. So please just watch out, specifically with this one, that tan 360 plus is deceiving, because you see 360 and you think you're in cos's quadrant. 360 plus, chop off that 360, and it's just the angle as is. And it stays positive. All right, for C, they've given you sine of 720 minus. So now, when you're working with 720 minus, you're going to subtract 360 off of it. All right, so if you subtract 360 off of 720, you are going to get 360 minus. So what they've done is they've subtracted it off twice to get you a negative angle. You don't actually have to do that here. I'm going to keep the 360 minus. So you only have to chop off one lot of 360 to get it onto your cast diagram, which is anything from 0 to 360. So I would keep it as sine of 360 minus, which is cos's quadrant. So sine is going to be negative anyway. If you used it as a negative angle, sine of a negative angle gets you negative sine of that angle. Right, tan of a negative angle is negative tan of that angle. All right, for this one now, they have said take off 360, you end up with sine of 360 plus alpha, and then the 360 plus isn't on the cos diagram, it's not the cos quadrant, so chop off another 360 and you get sine theta by itself. All right, so just look out for those little tricks there. Then let's use black. Tan of 360 minus, that's in cos's quadrant, so it's negative tan. So then we have our tans cancelling, and then we're left with our sine over sine, but with a negative, so cancel the sines, and you get negative 1. All right, then for E, we are working with sine of 180 minus, which is in sine's quadrant, so sine is positive, drop the 180. Cos of a negative angle is just cos of that angle. Sine of 360 minus is in cos's quadrant, so it's negative. And then we have this situation, which is the sneaky one. It looks like the reduction, but it's backwards. So because the 180 is negative, it's not on your cos diagram, I add 360. Or you have the option of taking out a negative and treating it as a negative angle. It's up to you though, but in this case, it's just a little bit easier just to add 360. So when we add 360 to it, negative 180 plus 360 gets us 180. So we're left with 180 plus the angle. And then, so that is in tan's quadrant, it is negative. Then we have our sines cancelling. Our cos is cancelling, and we have a negative times a negative is positive. And so our final answer is 1. Okay, now for G, we are working with still reductions and also still working with backwards reductions. So let's just start with the sine of 180 plus. Now please, unless there's a negative involved, if you have everything positive, you can just rearrange it. Both are still positive. There's no negative involved. You can just leave it as is. So that is going to get us tan's quadrant, which is sine is negative. Then tan squared of 180 minus. Now remember, that means we're in sine's quadrant, so it should be negative. But because we're squaring it, we get a positive tan. Then this one is the problem. Tan theta minus 180. Because you can't just switch it around. If you switch it around, remember, when we do switch arounds, you've got to take out negatives. So instead of taking out a negative, often the easiest thing here is just to add 360, which they've actually done over here. They've added 360. And so it becomes theta plus 180, which is the same as 180 plus theta. Okay. Then I'll come back to that step now. So then we have sine of 1080. So now 1080, if you subtract, it's much bigger than 360. So if you subtract 360, you get 720. If you subtract 360 again, you get 360. So again, like in question C, I would just stop at 360 and keep it as 360 minus. But they've taken off another 360 and just left it as a negative angle. It's fine like that too. But anyway, sine of, let's go with green, sine of 360 minus is still in cos's quadrant, so it's still negative sine anyway. All right, then my sines can cancel. And then at the bottom, we've got to still sort that out. My tan of 180 plus is in tan's quadrant, so it becomes positive. So then now I have tan squared over tan. Now imagine that this would be x squared over x. We'd cancel out with one of the x's and leave just the 1x. So in this case, it's tan. Tan squared over tan, we cancel out the denominator and we're left with just tan by itself. All right, I want to show you just the alternative here if you want to take out a negative instead of adding 360. Because you have to do that when you get ones with the 90 the wrong way around. So when you have tan of theta minus 180, if you were to rearrange it, you get negative 180 plus theta. I'm not switching, I'm just literally rearranging it. So my negative is still in the wrong place. I need it there. So the way we do that is to take out a negative. Like that. Right, and then you treat it as tan of a negative angle becomes negative tan of that angle. Right, and then negative tan of 180 minus is in sine's quadrant, so it's negative, and it's negative times negative is positive. So it still gets us that same answer anyway of tan theta. So it's up to you which one you want to use. Again, trig there's a lot of studying involved with trig. You have to know your theory, you have to know your cost diagram, you've got to know your negative angles, but there's a lot of room for manipulation. So you can kind of do things a little bit differently to the next person. All right, so you have to practice and explore this. All right, for I is another one where we're working with the backwards identity. So here we are working with adding 360. It then gets us to 180 plus. And then from 180 plus, it's in tan's quadrant. Tan is positive anyway. Tan squared of that positive is still tan squared x. Then for sine 540, it is bigger than 360. So we chop off 360 from it. And we are left with 540 minus 360 is 180, and it's 180 minus x then. 180 minus x is in sine's quadrant, so it stays positive. Then sine 180 minus at the bottom is in sine's quadrant, it stays positive. Then again, we have something that is definitely not right here. We have tan negative x minus 360. Focus on this negative 360. Right, and we add 360 because negative 360 is not on our cost diagram. We have 0 to positive 360. So add 360 to it. The 360s cancel and you're just left with a negative x. Tan of a negative angle is then going to get you negative tan of that angle. But first what they've done here is cancelled the signs. And then our tan of a negative angle is negative tan. Then we have tan squared over tan with a negative, so we keep our negative because positive over negative is negative, and cancel one of the tans. Tan squared over tan is just tan x. All right, so please, view these as variables. You don't know what sine x is, you don't know what sine alpha is, so it's like having x's. Okay, so then for k is sine 180 minus. Again, there's a serious lack of brackets here in this memo. Because in this case, there actually is a subtraction. So that is a subtraction. So it's hard to see if you don't have your brackets. Okay, so sine of 180 minus is just sine of that angle, because we're working with sine's quadrant. Cos of 360 minus is just cos of that angle, because we're in cos's quadrant. Cos of a negative angle is cos of that angle, it's positive. And then sine 180 plus is in tan's quadrant, so it becomes negative sine. Then at the bottom, again, don't be thrown by this because everything's positive here. It could be actually written as 720 plus alpha. Chop off 360 and you end up with 360 plus alpha. Chop off another 360, because if it's 360 plus, it's still not on our cast diagram. It's none of the formulas, so we take off another one. So we end up with just sine alpha. Then color. Okay, so when we're working with cos of 180 minus, that is in sine's quadrant, so it's negative. And then it's just a little bit of algebra here. So we end up with multiplying sine times cos is just sine cos. And then we have a negative sign times by the subtraction, so we get a positive. So we end up with sine times cos plus a sine times cos. We have 2 sine times coses. And at the bottom, we have sine times negative cos, which is then just, you can leave it like that. And then our sines cancel, our coses cancel. We're left with negative 2. Right, so please just watch your algebra here as well. Okay, last one for this exercise. And again, we're working with something that is a bit backward. Right, so because negative 540 is not on the cast diagram, we're going to add 360. So when we add 360, we still get negative 180. So we've got to add another 360. So that's why they've added 720 there. They've just done it all in one step. And so negative 540 plus 720 to get us onto the cast diagram is going to get us 180. All right, so you just add as many 360s or subtract as many 360s to get something that fits with the cast diagram. Then cos of 180 plus is in tan's quadrant, so it becomes negative cos. Just following through with this one, that sine 180 plus is also then going to be negative. So those all fit together. Then sine of a negative angle is negative sine of that angle. Cos of 360 plus is not on the cast diagram, so we chop off 360 and we're just left with the angle. Right, then for this next step, all they've done is they've said negative times positive there is going to get us the negative. So just doing some algebra there. Okay, so then for the next step, we end up with a negative sine over negative cos, which again, I would prefer an extra step here. So that becomes just sine over cos because the negatives cancel. And I'm minusing a sine over cos. So I have one sine over cos, and I take it away. So I'm left with nothing. Left with nothing. All right. Alternatively, you could have done an LCD and then worked it there, but it's not necessary if your fractions are the same. All right, so that's the end of exercise 3. You can practice the extra ones. Okay, so for exercise 4, I said just try A, 1, 3, and 5, and B, 1, and 3. You can try more if you want. This is using your co-ratios and negative angles that I have taught in the previous video. So now you must know your theory here. If you see a cos 90 plus, it changes to negative sine of that angle. If you have sine of a negative angle, it becomes negative sine of that angle. Top and bottom are the same, so they cancel out to become 1. For number 3, again, cos of 90 minus, you must know in your theory, becomes sine alpha. Then when you have sine of 180 minus, you think of your cast diagram. It means we're in sine's quadrant. Sine will be positive. So sine over sine is 1. Then we get to this one where they have 450, which is not on the cast diagram, so we subtract 360 off of it, and that gets us to 90. So the negative a stays, it's just the numbers that get affected. And you must know that cos of 90 minus becomes sine. Then sine of 180 plus is in tans quadrant, so it becomes negative sine. And then when we use a negative times a negative, it gets us positive. Positive. All right. Then at the bottom, we have sine of a minus 180. It's not on the cast diagram. Ours is 180 minus a. So you add 360 to any negative angle number there, and you end up with sine 180 plus. Remember, the a is already positive there. It doesn't have a symbol in front of it. It is positive. So we keep the symbol for the a. It's just the numbers that are changing. And then sine of 180 plus is in tans quadrant, so it becomes negative. They've lost their line. All right, so then you have at the top sine plus sine. You have two sines, like x plus x, you have two x's. Two x's. And at the bottom, you have still your negative sine. And so you can cancel your sines. And you're left with just the negative and the 2. All right, I'm hoping you're getting this. Otherwise, again, go back in the videos, go back to the notes, learn the theory that goes with it. Okay, so then moving on to question B, 1 and 3. We again have some new co-ratios. Remember, the 90 plus means co-ratio. So sine of a 90 plus becomes cos of that angle. Negative angle, tan of a negative angle is negative tan of that angle. If you ask why, it's theory that I've taught. You just need to study it. For the negatives, you pretend you're in cos's quadrant. Then here comes the problem one. When you have beta, here it's beta minus 90. You can't, so don't add 360 here, because then you're going to get to the 270, which is the other co-ratio, which we don't teach. So in this case, you have to take out a negative and treat it as sine of a negative angle is going to be negative sine of that angle. Again, they're just missing a step here. So that is going to become negative of the 90 minus beta. All right, so that minus there, I've just put in front here. So then negative times negative, that gets you the positive, and then they're saying 90 minus is getting you the cos there. So they're just skipping a few steps. I prefer if you don't skip any steps at this point in your life. So then we're working with tan of 180 minus is negative because we're working in sine's quadrant. So we're keeping the negative there. And let's just highlight where we're following this along. All right, so then, again, they're kind of missing some steps here. This in-between step here, cos times negative tan is going to be negative cos beta tan beta. It's like xy, negative xy. And then it's again a cos times negative tan. So this positive, that plus, that addition, is going to become a minus. All right, so positive, because effectively it's positive times another negative cos beta tan beta. So that becomes a negative. So you have negative cos tan minus another cos tan at the top. So that's where they're getting negative 2 cos betas tan betas. The bottom is still, we haven't done yet, so let's just go to that. Right, so tan of 360 minus is in cos's quadrant, so it becomes negative. And then at this point, we can cancel our tans, we can cancel our negatives, and you're left with 2 cos beta. So there's a lot happening, so highlighting does help, and also working slowly. With trig, we mark individual steps, so even if you keep the co-ratios till last, or you keep the reductions till last, we will mark everything else in between until you get to that stage. It doesn't all have to happen at once. All right, last one for this exercise. Sine of 180 minus is in sine's quadrant. Sine of a negative angle is negative sine of that angle. Careful, this is the exception rule. Cos of 90 plus gets us negative sine. And then we're sitting with a negative 450, so we're going to add on 360 here, and we get the 90. All right. Then let's just follow through here. Yellow and our pink over here multiply to get us a negative sine squared. So we're just going to keep that, following that through. And then our blue is just going to stay for a little while. All that's happening with this is that plus in front is just being multiplied to that negative. Okay, so let's talk about the denominator. I'll come back to the red bit now. Okay, let's just get a different color. Okay, so the sine squared 180 minus, oopsie, over there, right, is in sine's quadrant anyway, but because we're squaring, we'd always get a positive. So sine squared x, we're just keeping it all the way along. Okay, then let's deal with this red bit here. So cos of x minus 90 now, since we added 360. Now I've said when you have negative 90, you don't add 360 because it gets you the 270, which we don't use. So when you have the negative 90, you have to take out a negative. All right. Which is what they've done in that next step here. So they've taken out a negative and they've done a switch around. But the nice thing with cos is cos of a negative angle is just cos of that angle. Now in this case, the angle is 90 minus. So cos of negative angle is equal to just cos of that angle. And when you see cos of 90 minus, you replace it with sine x. Positive sine x. The only one that becomes negative is cos 90 plus. So that's where they're getting that piece there. Then for the next step, all they're doing is multiplying the two signs. The negative times negative becomes positive. They've actually, looks like they've made a mistake here. Let's just see. So we have negative sine squared x, and then they have, it should actually be positive here. Sorry. Let's just fix their answer. It should actually be positive. Positive sine 90 minus is positive, and cos is not affected by the negative angle. So we end up with negative sine squared x minus another sine squared x, which gets you to the negative 2 sine squared x over sine squared x. The sine squareds cancel, you're left with negative 2. Alright, the last exercise for this video, and for a while I'm just going to let you guys try and get your head around all of this and practice some extra from the exercises. Exercise 5, I said please try working on those selected questions. Try more if you want. Alright, so for exercise 5A, it's just asking you to calculate the following without a use of a calculator. So remember, without a use of a calculator, normally lends to special angles or cancelling or factorizing, something that, or even co-ratios that will cancel. Okay, so let's get into it. So cos of 120. Now you've got to have your cast diagram in your mind. So you have to know that your cast diagram, all students talk crap. We have theta, 180 minus theta, 180 plus theta, 360 minus theta. We have 0, 90, 180, 270, and then 360. Okay, so when you're working with a question, you've got to ask yourself, where is 120? It's bigger than 90, so we need to reduce it. 120 sits in sine's quadrant. So you have to say 180 minus what will give you 120. So it's going to be 60. But because we're working in enemy territory, we have a cos in a sine quadrant. It becomes negative cos 60. Cos of 60 is a special angle, which is equal to a half. So it's negative a half. All right, then for C, just trying to keep my cast diagram here. For C, we've got sine squared 240. So we need to ask ourselves, where is 240 in this situation? 240 is going to be in tans quadrant, between 180 and 270. 240 sits somewhere here. So 180 plus what will get me 240. That plus what is acute, so we are working with 60 degrees. But because we're working in tans quadrant, it actually should be negative sine of 60 degrees. But because we're squaring, we end up with a positive sine squared. Then sine of 60 is root 3 over 2. But remember, we are squaring it, so we end up with just 3 over 4. And it's handy, you can put in your calculator sine squared 240. You should get the answer of 3 over 4. Okay, so then moving on to D, we are working with sine 160. So you ask yourself, where is 160? It's sitting in sine's quadrant. So 180 minus what is going to get me 160? It's going to be 20 degrees. But because we're in sine's quadrant, it has to be positive. Then cos of 250. 250 is in tan's quadrant. So we say to ourselves, 180 plus what will get me 250? It's 70. But because we're in tan's quadrant with a cos, we have to have negative cos 70. Now, 20 and 70 are not part of your special angles. So that's why I say go look. If you can't work with special angles, try co-ratios. So co-ratios is saying that if you have a cos of 20, sine of 70 will match it. If you have a sine of 20 like we have and a cos of 70, 70 and 20 matches because they add up to 90. They have that complementary relationship. So sine of 20, I can change it. Its equivalent is cos of 70. Or you could change the bottom, the cos of 70, to a sine of 20. Again, use your calculators if you're a bit nervous to just change things. Check that they're equivalent. Sine of 20 in your calculator, if we type it in, is 0.34. So cos of 70 is also 0.34. So where I see a sine 20, I can put a cos 70. They are the same. Then the cos 70s cancel out and you're left with negative 1. Right, so you've got to look out for special angles, co-ratios, but the first thing you always work with is if you have angles bigger than 90, you reduce using your cast diagram. If you have negative angles, you get rid of the negative angles using the methods that I've shown in the previous examples and videos. All right, for G now. G is tan of 240. 240 is bigger than 360, so I go to tan's quadrant because that's where 240 is, and I say 180 plus 60 will get me 240, and because we're in tan's quadrant, we're getting tan as positive. Sine of 115 is in sine's quadrant. It's 180 minus 65. Now there's already a problem there. It's not a special angle, so it's probably a co-ratio. Then we'll work with cos of 330 is in cos's quadrant, so it's positive cos of 360 minus 30. So replace the 330 with 30 degrees. But then here comes a problem. Cos of 205 is in tan's quadrant, so we get negative, and it's 180 plus 25. Okay, so then the special angles you just need to fill in. But then we're working now with two that are 65 and 25 are not special angles, but they add up to 90. All right, so because they add up to 90, we can change one of them to the other. They are equivalent. So sine of 65 is the same as cos of 25. Okay, because 65 and 25 make 90, sine with cos, so you can exchange them. So then we're left with a cos over cos, which those will cancel. And then you just work with the numbers and don't forget your negative there. So root 3 over 2, the root 3's after you tip and times cancel out and you're left with just the negative 2. Okay, so the co-ratio ones are probably the trickiest ones to work with and to recognize. But as soon as you don't get a special angle and you're not allowed to use a calculator in the question, think, can I replace it and cancel it out? Okay, nearly done. So when we're working with I, Again, we look for reductions, we look for negative angles, and we try and just sift through all the information that we've learned. Okay, so this is for I. We have 4 more left after this. So tan of 225 is in tan's quadrant. It's 180 plus 45, which is a special angle of 1. Then sine of 240 is in tan's quadrant. It's 180 plus 60, so sine is negative sine 60. Cos of 330 is in cos's quadrant. 360 minus 30 will be the same as 330. Then I'm just skipping the one here. Tan of 150 is in sine's quadrant. It's 180 minus 30, but because we're in sine's quadrant, it's negative tan. Now, for the next one, it's up to you which method you want to use. I just prefer working with the negative angle, so it would be cos of 210, because cos of a negative angle does not get affected, which then is in tan's quadrant. It's 180 plus 30, so it's negative cos 30. What they've done here, instead, they've just added 360 onto the negative angle to get 150, which is now in sine's quadrant, so it still becomes negative, and 180 minus 30. So it gets you the same answer. So it's up to you which version you want to work with. I like just getting rid of the negative as soon as possible. Alright, so then, this one's quite nice. It doesn't have any co-ratios. Negative sine 60 is a special angle, negative root 3 over 2. Cos of 30 is also root 3 over 2. And now you can see that relationship. 60 and 30 make 90. Sine of 60, cos of 30 are getting you the same fractions. Negative tan of 30 is negative root 1 over root 3, or if you're using your calculator, it's going to give you root 3 over 3. So it just depends on which method you're using for your special angles. So you are more than welcome to have that as root 3 over 3. Okay, so it doesn't make a difference. It still ends up getting you to the same answer. Then you use your calculators or your brains or rough paper and you get your answer at the end. Okay, so moving on to J, and then I said what? J, K, M, and N. Okay, so J, negative angle. So sine of a negative angle is negative sine of that angle, and sine 45 is a special angle. Cos of 315 is bigger than 90, so we're going to reduce. It's in cos's quadrant, so it's 360 minus 45, but cos will be positive in its own quadrant, and we have a special angle. Again, look at the fact that sine of 45, cos of 45 are getting us the same fractions as each other, and that's because 45 and 45 make 90. They are co-ratios of each other. Right, then cos of 215 is in tan's quadrant, so we get negative cos and 180 plus 35. That's not a special angle, so we're going to be getting a co-ratio here. Alright, so we're just going to keep that there. Then we're going to work with sine 305 is in cos's quadrant rather, so we get negative sine of 360 minus 55. So 55 replaces the 305. Alright, so then that's also not a special angle. It's probably going to work with the green cos 35. Then tan 750 is bigger than 360. So if you take off 360, take off another 360, you eventually get down to something on the cast diagram of tan 30, which is a special angle. Then, let's pick another color, tan of negative 300. Again, they've just added 360 to get you tan of 60. I would first go tan of a negative angle is negative tan of that angle, and then this takes you to cos's quadrant, which means it's negative tan of 30. The negatives cancel. Sorry, not negative tan of 30, negative tan of 60. 300 is 360 minus 60. And positive, negative times negative gets you the positive. It stays the same. All right, so, and then that is a special angle. All right. Have a look now at what they've done is they've changed the negative sine 55 to a negative cos 35. Because 35 and 55 make 90. So sine and cos, their angles adding up to 90 are equivalent. So sine of 55 is 0,819 and cos of 35 is the same. All right, so you can check it in your calculators. You could have also changed the cos up there, cos 35, you could have changed it to a negative sine 55. It doesn't make a difference. Sine to cos, cos to sine, they're equivalent. All right, and then those two will cancel out, and then the rest are just numbers. Then you just multiply and sort it out. All right, nearly done. Okay. Sine of 705, we take off 360, and we get sine 345, which is in cos's quadrant, 360 minus 15, but we're in cos's quadrant, so it's negative. Then again, they've just added on 360 here to get us tan of 45. You could have also just said tan of a negative angle. Negative tan of the angle lands you in cos's quadrant, which is negative, so the negatives cancel and you still get tan 45, which is a special angle. Cos of 300 is in its own quadrant. It's 360 minus 60. But it's positive because it's in its own quadrant, which is then a half. Then we will look at, let's see, sine of 150 is in its own quadrant. It's 180 minus 30, but it's positive because it's in sine's quadrant. Sine 30 is also a special angle. Let's go to yellow. Okay, so then cos of negative 75. Cos of a negative angle is just cos of that angle. See, they've chosen not to add 360 to it. They just said cos of a negative angle is not affected by the negative, and so it goes straight to cos of 75. Now, 75 is not a special angle, and neither is the sine 15 in the next step. So what they've done is they've realized that 75 and 15 make 90, so cos of 75 must be the same as sine of 15. Because cos of 75, sine of 15 add up to 90. They are the same as each other. So then we can cancel out our sine 15s and then just work with the numbers. Don't forget the negative there. All right, last two, m and n. Okay, so we're working with tan of negative 60 is, you could either add 360 or you could just say, well, tan of negative 60, tan of a negative angle is negative tan of that angle, special angle. Right, then sine of 158 is in sine's quadrant between 90 and 180. So we are saying it's 180 minus something will get me 158. It's 180 minus 22. It stays positive because it's sine's quadrant. Sine of 120 is in sine's quadrant, so 180 minus 60, but it stays positive. And then just make a big note for yourself. This is an actual addition happening in the question. All right, then we're working with cos of 248 is in tan's quadrant, and so it's 180 plus 68, but it becomes negative because we're working in tan's quadrant, an enemy quadrant. Let's go with cos 570. If I take off 360 from it, so 570 minus 360 does get me cos 210, which is in tan's quadrant. It's 180 plus 30, but because it's tan, it's negative for cos, and then that gets us a special angle down there. All right. That sine is a special angle. And then they've just gone a step ahead to combine the purple and the green into just a common denominator there, because you have negative root 3 of sine. Wait, I'm jumping ahead, sorry. Let's come back to that. So just to clarify, remember we need special angles or co-ratio. So this negative 68 is going to be the same as negative sine 22, because 68 and 22 make 90. But that negative is going to hop and change the addition to a subtraction. So that's where they're getting that piece from. Oops. That piece from. So you have a negative, sorry guys, I will get used to the highlighting, the negative root 3 of this angle minus root 3 over 2 of the same angle. So imagine it could have even been x. So you have negative root 3x minus root 3 over 2x. But instead of x, we're saying we're working with the angle of sine 22. But because it's not special, you don't know what it is without a calculator. So you have negative root 3 of those things minus another one. That's where we're getting this piece here. So negative root 3 minus root 3 over 2. Pop it in your calculators or do a little LCD on the side. It means you have negative root 3 over negative 3 root 3 over 2 of those sine 22s. Then our sine 22s can cancel. And then it's just working with the numbers. All right, last one. No, it's been long for me as well. Let's do this. Okay, and then we're going to take a bit of a break for a few days just to let you figure this stuff out. So then sine 300 is in cos's quadrant from 270 to 360. So it's 360 minus what? 360 minus 60 would get me 300, but I'm in enemy territory, so I need negative sign. It's a special angle, so we can replace it with its value. Cos of negative 375, again, they've just added 360 to get the cos of negative 35. Cos is not affected by a negative angle at all. But we got to keep it there. It is not a special angle. All right, then cos of 210 is in tan's quadrant, so it's 180 plus 30. Is 210, but it's negative because we're in enemy territory. Then sine of 235, if you reduce it, it's in tan's quadrant. It's the same as sine 55, but it's negative because we're in tan's quadrant. Again, not a special angle, so we're going to have to work our way around that. Tan of 150 is in sine's quadrant from 90 to 180. So it's 180 minus 30 will get me 150, but it's negative. It's a special angle though. Cool. Then sine of 775. If you keep taking off 360, eventually you get to sine 55, which is on the cast diagram. Then, what color haven't I used? Green. Cos of negative 30 is just cos of 30 degrees. It's not affected at all by your negative angles. And so it's a special angle, and that was also a special angle. So then now, you get to choose. Either you're going to change to sine 55s or cos 35s. Just the last one there, cos 215 is in tan's quadrant. It's the same as 180 plus 35, but it's negative because we're in tan's quadrant. All right, so what the memo has done here is just changed everything to cos 35s. So using the co-ratios, 55 and 35 make 90. And then, all right, so then just working with where this, so it's a bit hard to see sometimes with so many things. Just maybe skip some lines. So this negative times negative makes a positive, but then times another negative, it stays negative. And then we're working with, let's pick a completely different color here. This negative times positive gets you a negative there. So at the top you have negative root 3 over 2 times cos 35. and now you're taking away another negative root 3 over 2 cos 35. So that means you have, in your calculators, root 3 over 2 negative minus another 1 just gets you root 3. So that's where that piece came from of cos 35. It's like saying negative root 3 over 2x minus another root 3 over 2x. Then at the bottom, same story, you're going to have a negative 1 over root 3, or if you're using your calculator, it would be root 3 over 3 minus another root 3 over 2, and that gets you this negative 5 root 3 over 6. So I would suggest you use your calculators for that. Even though the question says without a calculator, we don't need to mess up on the arithmetic. So just don't give us decimals, because then we won't know that you've used a calculator. Okay, so be smart about it. The cos 35s are going to cancel, and we're left with 6 over root 5. So again, please treat these as almost like variables here, because you don't know what they are. So it's just algebra in that case. So please don't try. Also, you're not allowed to do the following. I'm going to put in big. You're not allowed to cancel here, right? Even though it's got the same effect, you're not allowed to cancel because you are working with a binomial, all right? So please don't do that. What you could have also done is taken out a common factor at the top. That's not such a bad idea. Take out a common factor of cos 35, and you would have been left with the same thing, negative root 3 over 2 minus a root 3 over 2, all over, take out a cos 35 at the bottom, and you're left with negative 1 over root 3 minus root 3 over 2. Again, that is using the old school method for the special angles. If you use your calculator or the method that I learned in school, it would be root 3 over 3. So whichever one fits with your method, right? And then your causes cancel, and then you can just work with the numbers. So there are variations to this. Okay, grade 11s, I know it's been a bit of a brain overload, but I'm hoping that something has gone in, and I'm hoping that you'll go over this video a few times, and you'll try and work on the exercises and try and work on the other questions as well by yourself. Trig, you cannot work with if you firstly don't know your theory that we've taught, and secondly, if you haven't practiced. So please practice, practice, practice.